Here is the question. A material P of thickness 1 mm is sandwiched between two steel slabs as shown in the figure below. A heat flux of 10 kW per meter square is supplied to one of the steel slabs as shown. The boundary temperatures of the slabs are indicated in the figure. Assume thermal conductivity of this steel is 10 watt per meter Kelvin. Considering one-dimensional steady-state heat conduction for the configuration, the thermal conductivity K in watt per meter Kelvin of material P is. So, this question was asked in GATE 2014, set 2 for 2 marks, and it is a numerical ability type question. Here, in the question, it was given as heat flux. So, heat flux is 10 kilowatt per meter square. Heat flux Q is heat transfer per unit area. Heat flux small q is heat transfer rate per unit area. So, it will be usually in terms of watt per meter square or kilowatt per meter square. So, while solving this problem, we need to convert this into watt per meter square in order to maintain the dimensions on either side properly. Then the temperatures of the slabs are indicated in the figure. T1 is given as 500 Kelvin and T2 is 360 Kelvin. All the dimensions that are given are in mm here. Now, let us solve this problem, and this problem is related to composite slabs. Now, we know that heat transfer rate Q is always the overall temperature difference by thermal resistance sigma RTH. Now here let us consider this as first portion, this as second one, and this as the third one. Here we can write this as Q is equal to overall temperature difference is T1 minus T2. We need to consider this temperature minus this temperature divided by, as there are 3 slabs, we need to consider RTH1 plus RTH2 plus RTH3. So here thermal resistance RTH is L by Ka. Now we need to consider this as L1, this as L2, and this is L3. Now as the dimensions are given in mm, we need to convert them into meters while substituting. So therefore, we need to take L1 as 0.02 meters, L2 as 0.001 meter, L3 again 0.02 meters. Now, the thermal conductivity of steel slab is given, that is K1 equal to K3, and that value is given as 10 watt per meter Kelvin. We need to determine thermal conductivity of material 2, K2 equal to Kp, thermal conductivity of material P we need to determine. So, let us consider this like this: Q is equal to T1 minus T2 by L1 by K1A plus L2 by K2A plus L3 by K3A. Now, we need to consider the area that is perpendicular to the heat flow direction, and that area for these 3 slabs will be same. So, I can rearrange this formula like this: Q by A is equal to T1 minus T2 by L1 by K1 plus L2 by K2 plus L3 by K3. Now, let us substitute those values: 500 minus 360 divided by L1 is 0.02 divided by K1 is 10 plus 0.001 divided by thermal conductivity K2 plus 0.02 by 10. Now, this Q by A is equal to small q heat flux, So from this, we can take 10 into 10 cube. We need to convert kilowatt per meter square into watt per meter square. So 10 into 10 cube equal to 500 minus 360 divided by 0.02 by 10 plus 0.001 by K2 plus 0.02 by 10. On solving this, we are going to get the value of K2 as 0.1 watt per meter Kelvin. So, the thermal conductivity of material P is 0.1 watt per meter Kelvin. As this is numerical type question, we need to substitute 0.1 here. And this is the end of the explanation for this question.